Hello everybody, today I'm going to be checking the solution to an integral that I did and my video was featured on Blackpin Redpin's page. There will be a link to his YouTube channel and the specific video in the description, and so you can see the integral and how I did it. And so now in this video I'll be checking that this is in fact the solution to that integral, and I'll be checking it by just taking the derivative. So let's go ahead. First term, first of all, we're going to be using the chain rule a lot. Anyway, so first we have 1/3 times, and so we drop the 3/2 times x plus square root of x squared plus 1 to the 1/2 minus, oops, I forgot. Now we have to multiply, so that was basically the power rule. Now we have to multiply by the derivative of this part, which is 1 plus x divided by square root of x squared plus 1. And so that is this term differentiated. Now we just have to differentiate this term, and it's not all that different. So we have minus, then we can drop the negative 1/2 times x plus the square root x squared plus 1 to the negative 3/2 times, again it's going to be the same portion here because we have the same inside functions, 1 plus x divided by the square root of x squared plus 1. And so now I'm going to factor out quite a bit. So we can notice that this negative and this negative go away. So that's just a plus. And now I'm going to factor out, oh, and also this 1/3 and this 3 cancel. So now I'm going to factor, and I'm going to have 1/2. I'm going to factor out this 1 plus x divided by the square root of x squared plus 1 term, but I'm going to put it into one fraction, like so. Okay. And then I'm going to factor out this term, which is, if you look at the video, this is exactly what the integrand is. It's the square root of x plus the square root of x squared plus 1. And so we would expect everything else to cancel out to 1 in order for us to get just this result. So now we basically factored out this entire term. So here we just have a 1. And then here we get rid of the 1/2 and we get rid of this term. Here we've essentially divided by x, x plus to the 1/2. And so this will become, instead of a negative 3/2, we'll have a negative 4/2, which is a negative 2. So we have plus 1 over, so I'm taking the reciprocal because of the negative, 1 over x plus square root of x squared plus 1 squared. Now, what we can notice is that if we look at this fraction, and I'm going to write it with the radical first. What we can do is take the conjugate, and basically all that means is that we're going to multiply the top and bottom by x, the square root of x squared plus 1, oops, minus x. And it's pretty easy to see that this will never be 0 because this is basically the square root of x squared plus 1, and this is the square root of x squared. X squared plus 1 is always greater than x squared, hence this will never be equal to 0. So we can justifiably multiply the top and bottom by it. But now in the bottom, in the denominator, we have a difference of squares. And this becomes x squared plus 1 minus x squared, which is just 1. So this whole thing comes out to be the square root of x squared plus 1 minus x. Which means that over here, this stuff will have 1 plus the square root of x squared plus 1 minus x. Now, and squared. Now we can just expand this, right? So we have 1 plus x squared plus 1. Sorry, that 2 failed. Plus x squared. I just like to write the squared terms first. Minus 2x times the square root of x squared plus 1. And now we can group these terms together. So we have 2 x squared plus 1. Wow. Minus 2x times the square root of x squared plus 1. And so this is replacing this. And so we notice that this 1/2 here will nicely cancel out with these 2's. And we can do a little something crazy here and factor out a square root of x squared plus 1. Usually you don't factor out radicals, but in our case, we'll see that here we'll just get another square root of x squared plus 1, because basically x divided by square root of x is square root of x, minus x. And that is what used to be here. Now notice that in this term, where we have x squared plus 1 plus x divided by the square root of x squared plus 1. And notice, so I'll write that here. So we're multiplying by the square root of x squared plus 1 plus x all divided by square root of x squared plus 1. Well, now these terms obviously cancel. And now we're left with this difference of squares again, which we've already seen is equal to 1. And so, like we wanted, everything except what we had as the integrand just cancels to 1. And so that means that just our integrand is left after differentiating. So therefore, our derivative The derivative of our integral equals the original expression, so unless we made two mistakes, which we probably didn't, the answer is in fact correct. Thank you for watching, and be sure to check out Black Pen Red Pen, even though you probably came here from him. Thank you.